Climate change is the greatest threat to all life on Earth. With our ever-expanding population and our ever greater reliance on the Earth's natural resources, we are having a tremendous and largely negative effect on the natural world. This is evident in the fact that we are having to respond to those negative effects today. Droughts, poor air quality, loss of biodiversity, extreme weather events, rising sea levels and flooding. That is why we must put carbon emissions at the heart of everything we build, actively choosing the lowest carbon solutions through the design, construction and operation of our assets. In this video, we're going to explore carbon through the lens of schemes that have been delivered across the Eastern Hub over the past few years, and hear from professionals who work amongst the CDF teams.
This is a drone video of natural flood management measures we have delivered in the agricultural fields bordering the Little Stock Brook. The project has delivered a series of field corner bunds, planted 13 hectares of riparian woodland, utilised local contractors and sustainable construction techniques. NFM presents a fantastic opportunity to deliver multiple benefits and to contribute to our net zero carbon targets. A carbon assessment of the project is evaluating the balance of carbon expended during construction versus the longer term carbon sequestration gains.
In the Broads here, managing flood risk has always been challenging. We've got long lengths of embankment sitting on very poor ground conditions in an area with the status of a national park. What we need to do, because we get very limited resources in terms of flood risk management, is to maximise the return that we get for whatever investment we put in. And the type of things that the partnership with the private sector has brought to this project in terms of long-term planning, efficiency savings, value engineering and a degree of innovation, I think has been a really successful outcome from the Environment Agency's perspective.
As we travel up the river here, you can see the full impact of the project. You have the old steel sheet piling on your left-hand side, still in place with the flood bank sat on top of it, and on the right-hand side you have our new flood bank which has been set back, and you now have a reeded edge to the river rather than the sheet piling. And the reed extends for some 20 metres before you get to the flood bank, and that is now the erosion protection for this section of river.
Basically these guys are repairing this sheet pile wall down here, and they're using an innovative method known as limper dam. So instead of pulling all these piles out and renewing all the structures, they've basically got this small piece of equipment here. They can go down, drop it into the river and make repairs and put cathodic protection onto the piles themselves. So why is that good for sustainability and energy? Well, obviously it's clearly using a lot less plant. They're able to just make the repairs and not have to use all this big heavy piling equipment to renew the walls. And plus, added benefit with cathodic protection is it will last a lot longer. So they're doing a really great job of sustainability. Now at the moment, they're having to do this in two different ways. Obviously behind us, they're not able to put trains on the land. But up there, you can see a different piece of work. They're able to do that. What we're standing on at the moment is jack-up barge. So they're having to do these piling operations and repairs of the jack-up barge themselves. So a little bit more energy intensive, but it's something to consider with this type of work. But still, they're saving absolutely thousands of tonnes of carbon emissions, not using extra materials, using a lot less energy.
We will need many different approaches to reach net zero emissions. These are likely to include more renewable electricity generation, an increase in the number of electric vehicles, and better energy efficiency in homes and offices. Partnerships can help to deliver this, and the Environment Agency Osney Lock Hydro and Energy Storage Scheme is a great example. A community hydro turbine supplies renewable energy to an office and also charges the workplace fleet of electric vehicles. Innovation has helped to ensure that any excess renewable energy generated is stored for later consumption.
Hi, my name is Steve Taylor. I am an Environment Agency senior user. This is the Houghton Brook flood storage area, which ultimately will be a statutory reservoir and will provide a flood risk alleviation to around 250 properties in northwest Luton. BAM Nuttall, our professional partners, are the main contractor, and early in the construction phase, BAM identified a carbon saving opportunity that we could replace the current in situ concrete design of stairs that go over the embankments with a 3D printed design which would be built within a factory and result in a 60% reduction in concrete volume, and as a result of this the likely saving in carbon is likely to be in the order of 20 to 30%. So I consider this to be a good example of a contribution towards our overall targets of carbon saving.
With NFRM and large-scale attenuation solutions unfeasible at Boston Barrier, the option was only to invest in substantial capital infrastructure upgrades. The installation of a 362-ton steel gate, which is the largest in Europe, is the centrepiece of the scheme, which also includes renewal and elevating of several hundred metres of river walls. Clearly the carbon footprint of the scheme was going to be substantial. So what did the delivery teams do to mitigate this? Cement replacement was increased to 70% within the 12,000 cubic metres of concrete used. This was done primarily on constructability benefits, but nonetheless mitigated almost 1,000 tonnes of carbon. The project secured grid power connections to avoid the use of diesel power generation. This has mitigated in excess of 200,000 litres of fuel and 500 tonnes of carbon. Digital construction also played a key role in mitigating construction process inefficiencies. In particular, the understanding of the complex steel reinforcement design in a digital model avoided errors in the construction, reduced waste, and improved productivity of the whole construction process. The design also considers future maintenance. Hydraulic pipework, for example, has been relocated within the structure to allow for easy replacement at the end of their life. But by far and away the biggest carbon saving is in fact that we are constructing something here which isn't just fit for today's challenges, but also for tomorrow's challenges. Boston is a great example of this and an excellent showcase of sustainable design and sustainable construction.
As designers, we have a really significant opportunity to reduce carbon because we're involved at the earlier stages of a project. So we get involved at the build less and the build clever stages, and even at the build nothing stages of a project. And we can really influence and help shape the project and the direction it takes. And working in collaboration with our contractors is also really important because it means we're designing lower carbon solutions that can be implemented at the construction phase of the project. So a really good example of this in Hub C is the Reading and Caversham project. The design team undertook an investigation into low carbon and ultra low carbon concrete alternatives and looked at areas within the design which could be suitable for these more novel materials such as SEM-free. And in doing that, they identified a potential carbon savings of 422 tonnes of capital carbon.
Hello, I'm Martin Gibson. I think we all know it can be very difficult finding ways to drive down carbon emissions. And last year, Thames Area decided that it would be a good idea to have a carbon specialist to help teams and individuals to find ways to drive carbon emissions. And so I've been helping people to understand where carbon comes from and how the decisions they make affect carbon in both schemes that we're building and in operations. I've been helping people by looking at how they interpret the results from carbon calculations and giving them information and guidance and often support on new materials to use that have lower embodied carbon. And I'm convinced with our enthusiasm and skills we'll be able to drive down carbon emissions dramatically. Although it will be a challenge to meet our zero emission target for 2030, I'm convinced we can do it.